Okay, we're going to do a quadratic regression equation. Josie hit a golf ball from the top of a hill. The height of the ball above the green is given in the table below. And it says for A to describe the characteristics of the data, and for B to determine the equation of the quadratic regression function. Now, as we've talked about before, the first thing you want to do is enter this data into your calculator so you can get a visual on your graph of what this data is going to look like. So you're going to press the Stat button. You're going to go into number 1, Edit, and you're going to want to enter your data into L1 and L2. So I've already entered the data. You can see that I've entered the time into L1, 1, 2, 3, 4, and 5 seconds, and I've entered the height in meters into L2. And I'll just make a note of that on my graph. Now, in order to visually see this, we need to go to Second Stat Plot. We need to turn our stat plot on. We're going to choose our scatter plot type and make sure that our data is going into X and Y. So L1 into our X are our X values, and L2 are our Y values. And then we need to choose an appropriate window. Okay, our time is going from 0 to 5 seconds, so you can choose 0 to 5, you can choose 0 to 10 if you want. Choose an appropriate scale. And then for our Y values, we can see that a height below 0 definitely would not make sense. So we can start with a Y minimum of 0. And our values are going from 16 to 75. So maybe a Y maximum of about 100 meters would be appropriate. Now let's take a look at what this looks like. As you can see, this has a nice parabolic shape. So for describing the characteristics of the graph, we have a parabola. And we can also note that it's opening downwards. Now we want to determine the equation of the quadratic regression function. Now in this case, it's telling you that it's a quadratic regression function. But if you weren't sure, by just looking at the data, when you're looking at this graph of the data and you're seeing the nice parabolic arch shape, you should be able to recognize that this is a quadratic function. Now what you're going to do is you're going to go into Stat, you're going to scroll right to the Calc label, and you're going to choose number 5, Quadratic Regression. Now it's saying that your X list is in L1 and your Y list is in L2. That's already done for you. And we want to store the regression equation into our Y1. So you're going to press vars. You're going to scroll right to Y vars. You're going to choose number 1 function, and you're going to choose number 1 Y1. You want the equation to be stored into Y1 after it's calculated. Now you're going to go down to Calculate, press Enter, and it's telling you that the equation has an A value of about -10 or 10.1, a B value of 51.4, and a C value of 11. So let's just copy that down here. The equation of our function is y equals negative 10 point, let's keep 2 decimal places, 10.07 x squared plus 51.41 x plus 11. Now it's asking us to use our equation to determine the height of the ball at 0 seconds, at 2.5 seconds, and at 4.5 seconds. This can all be done on your calculator. Now you'll note that these are all times, so each of these values are x values. If you're trying to determine an x value from your graph, it's really simple. You're going to go into your graph, and you're going to see that our equation has been stored, and now you can see the entire equation, or the entire graph of your equation. And you're going to go into Second Calc, and you're going to go to number 1, value. If you know x values, you can plug any x value into your calculator. So at x equals 0 seconds is our first one. We press enter. It's telling us our y is 11. So 11 meters is our y value. And at 0 seconds, that's going to be the original height of the ball. So that's going to be the height of the hill, because Josie is on the top of a hill when she originally hits the ball, which is why at 0 seconds the ball is already 11 meters above the ground. Then we can do it again, second calc. We go to number 1, value, and we put in 2.5 seconds. And it's going to tell us what the height of the ball is at 2.5 seconds, 76.575 meters. So we'll just round that to 76.6, so 76.6 meters. And for the third height, we know that it's going to be on its way back down. Second calc, value, can plug in any x value. We want to plug in 4.5 seconds. And the graph tells us that the ball is going to be at a height of 38.4 approximately meters above the ground at 4.5 seconds. Now it's asking when the ball hit the ground. Remember that the ground represents our height. So the ground has a height of 0 meters. And then as the ball moves above the ground, that's when our height increases. So we want to basically figure out when is our height equal to 0. Now you might remember from previous math courses that we can use the 0 function on our calculator in order to find the time when the height is 0. So you're going to press second calc. You're going to go to number 2, 0. You need to go to the left side of the ground. Press enter. Move to the right side of the ground, so you're not going to be able to see your cursor. Press enter a third time, and it says that the y has a value of 0 when x is 5.31 seconds. So that means that the ball is going to hit the ground 5.31 seconds after Josie hits it off the top of the hill.